Okay, finishing up our lesson on tangents and circles. We have one more theorem. I think this one most people find to be a slightly easier one to understand, mostly because you can kind of see the way it looks. The theorem says that if two segments from the same exterior point are tangent to a circle, then they are congruent. So what does that mean? So we have an exterior point, some point outside the circle. That's B. That's way out here. If the two line segments that go from B hit the circle at a point of tangency. So point C right here is a point of tangency, point A is a point of tangency. If that's the case, that line segment and that line segment are congruent. They have to be the same length. So basically, and I'm sure you guys can see this if you kind of turn it to the side a little bit, if you have this little ice cream cone looking shape, um, then the two line segments that basically form the cone part have to be congruent. They do have to actually hit the outside of the circle. They have to be points of tangent. But if you have that, they're always going to be congruent. So let's take a look at the example that we have down here at the bottom and see how this works. So it tells us that AB and CB are tangent to circle D. So they're telling us that both of those are tangent. They both have the point at B, which is outside of the circle. So they just want us to find the value of X. Because they are both tangent, this one and this one are congruent. So X plus 15 and 2x minus 5 must be the same. So we have our equation. X plus 15, man, if I could learn how to write, X plus 15 equals 2x minus 5. And now we have an algebraic equation to go ahead and solve for X. So using some of our algebra skills, we are going to subtract X on both sides, which is going to leave us with 15 equals X minus 5. And then one more step, we will add 5 to both sides. And we get that 20 is equivalent to X. And we've solved for X. Obviously, if we wanted to find out the length of the side, you would just plug it back into either one because it should be the same. Okay, more examples. Again, pretty much the same. Find the length of FG. So they actually want us to find the length of that piece right there. Well, to find the length, we need the value of X. It looks like FG and GH are both tangents because they hit the outside of the circle. So that means this one and this one have to be the same. So 5x minus 9 has to equal x plus 7. So again, algebra, let's take x away from both sides. So that'll be 5x minus 1x, which is 4x. Bring down the minus 9. X's are gone on the right. Bring down the 7. We'll add 9 here to both sides, which means that 4x now has to equal 7 plus 9 is 16. And we will divide both sides by 4. So then x should be 4. But of course, that's not the finish to the problem because they do want us to find the actual length. So they want us to find FG, line segment FG, and that's going to be by plugging that 4 back into x. So that would be 5 times 4 minus 9. 5 times 4 is 20, minus 9 is 11. And technically, I could have plugged the x into that one as well and gotten 11. 4 plus 7 is 11 because they should have been the same. But I just used the one that they actually told us to use. So either way works. Okay, next example. Determine the length of FE. So once again, they want us to find the length of one of these pieces right here. That one. And again, you got the snow cone looking thing, so it means that these two pieces here are equal because these are tangents of the circle. So it looks like 2 parentheses x plus 16 has to equal 6x minus 4. So just incorporating some more of our algebra. Let's go ahead and distribute 2 into the parentheses, which should give us 2x plus 32 equals 6x minus 4. I'm going to choose to subtract 2x on both sides. Again, there's many things you could do here first, but to me that one just makes the most sense. So then we'll have 32 equals, let's see, 6x minus 2x is 4x. Bring down the minus 4. Let's add 4 to both sides. So that'll give us 36 equals 4x. Dividing both sides by 4, we get that x is equal to 9. And again, what they want us to find is the actual dimension or the measure of FE. Again, technically you could use either one, but I'm going to use the one that they asked for. So that'll be 2 times, plug in the 9, plus 16. Order of operations, 9 plus 16 inside the parentheses is 25, so that'll be 2 times 25, which is 50. And again, had you plugged the 9 into the bottom one, it still works out to be 50. Okay, a few more examples and we will be done. Determine the length of RS. So once again, they are looking for the length, not just the value of x. Here's the interesting thing about this one. We know that they have to be the same, so we can set up 2x plus 3 is equal to 25. Watch what happens. We're going to subtract 3 on both sides, which will give us 2x equals 25 minus 3 is 22. We'll divide both sides by 2, which makes x equivalent to 11. But they are looking for the length of the side. If you haven't already figured this out, if you have figured it out, good. If you haven't, we'll see what happens. So RS, if I plug the x back in, is going to be 2 times 11 plus 3. Well, 2 times 11 is 22, plus 3 is 25. Hopefully you recognize that that is the same as TS. Did I really need to go through all of that work to figure that out? No, I did not, because if they are the same length, they told us that one is 25, which means the other one had to be 25. So I didn't have to go through all that work, but if you did, it still works out. Okay, next example. The length of RS. That is this one. Again, we have the snow cone, so we know they're equal. This one you actually do have to solve. So x plus 12 has to be equivalent to 4x plus 9. Let's take away x on both sides, making 12 equivalent to 3x plus 9. Let's take away 9 on both sides. So 3 is going to equal 3x. And then we divide both sides by 3. So then x is going to equal 1. And since we are looking for the measurement of RS, we're going to do 1 plus 12, which is 13. Okay, we got one more example to do. If you want to, go ahead and give this one a shot yourself and then come back and see if you got it right. So pause the video, set it up, and see what you can do. Okay, this one they are actually asking us to find the value of x. So we really just need to set these things up. It tells us that LM, which is this one, is 4 times x minus 10, and that NM, which is this one, is 2 times x plus 10. We know they have to be equal to each other, so we will do that. 4 times x minus 10 has to equal 2 times x plus 10. So let's go ahead and distribute to do our algebra. So that'll be 4x minus 40 equals 2x plus 20. Okay, so I'm going to take away 2x on both sides, which will leave me with 2x minus 40 equals, the 2x's on the right will go away, equals 20. Let's go ahead and add the 40 to both sides to get rid of it. So that'll be 2x equals 60. And then we will divide both sides by 2. So x will equal 30. And that's all it was asking us to find, was the value of x. So we are done. Obviously, we could plug it back in to find the length of each side, but that's not what it asked. All right, much shorter and easier as long as you're okay with the algebra behind this, because it's pretty much the same thing over and over again. Again, it just has to be two lines which are tangent to the circle with some other line, with some intersecting point on the outside. Basically, it forms like a snow cone looking thing. All right, last slide on here. You all have some delta math, which will be due at the end of the week. That is the end of our lesson.